Hello, everyone, and thank you for joining today. My name is Jeff Peoples. I'm a senior product manager here at Parasoft, and today we're going to be talking about the biggest challenges testing teams face, and that's test data. Let's cover a little bit of housekeeping before we get started. If you have any questions, feel free to drop them into the Q&A box, and I will get to those at the end of our session. So, just a little bit of information on where we're going to cover today: test data. And I'll cover some statistics that we've found among our customers and the time drain that is waiting for test data to extract it, to provision it, and the various limitations and approaches companies have taken to deal with those challenges. So let's get started. Everybody needs test data. And there are a lot of challenges on this particular topic, and I'm going to walk you through some of the traditional ways of resolving these types of issues. And then I'm going to take you through some new functionality that we have developed here at Parasoft that will make this entire process much easier. In addition, we're going to be talking particularly about how combining test data with service virtualization can provide a powerful solution to help us resolve these types of challenges. A good place to start is to have a conversation about the test data problem itself. We've recently done some research among the organizations we work with, and there's a lot of compelling information out there about the challenges we're seeing in our industry that, at the core, boil down to test data issues. And in fact, here are some numbers associated with them. We find that up to 60% of time spent working on test cases are actually spent with data-related tasks. And those data-related tasks can be different types of things, such as trying to find the right data for an application in order to run the tests you need. They could be related to recovering or repairing test cases because they had the incorrect test data. They could be spent waiting on test data management team to provide the right data, and so on. But as a result, what we see is there are many projects that end up overrunning 46% due to cost and 71% due to falling behind schedule due to the inability to provision correct data. What ends up happening is that because of these overruns or lack of test data, testers just end up doing less testing, and that lowers test coverage, which of course leads to lower quality and more defects in production. And what we see traditionally are three approaches that can be taken toward test data creation. And now there are pros and cons to each of these, and I'll just go into a few for each one. So the first is to simply copy the production database itself. While indeed the simplest of the solutions, you can imagine it has all kinds of challenges. So like a great many production databases are huge. And the database administration teams would be dealing with the time it takes to copy the entire database, as well as the infrastructure costs to store and manage all that duplication of the data. And then you have to deal with the fact that there may be a personally identifiable information or PII that would first have to be masked before you could load it into your test environment. And above all, do not forget to mask. And when you do, don't miss anything. So a solution to the first approach is to simply take a subset sample of that entire production data. Now, the pro here is that you're no longer dealing with massive amounts of data, but the con is who makes the ultimate decision about which data is important. And once that decision is made, how are we sure we have maintained referential integrity so that we don't break some other test because we didn't have the right data in our subset? Each individual tester may have their own data requirements. They may need their test data in a specific state, and coordinating that activity of pulling in just the right slice is a difficult task in itself. And then here we have the same issue of PII and having to mask data and all that that entails. Once again, do not forget to mask. So the third option, and the one we see most of our organizations going to, is to simply synthesize the data. Now, this is great because we can choose which types of data to generate and satisfy each of the different use cases. And we don't face any issues with PII for masking because we generate the data from scratch. But the challenges here are that we can't just generate the data in a vacuum. We have to understand to a detailed level the data that's in the database so we can understand the rules and relationships and how the keys relate to each other. And we face that same issue we faced before. Did we generate the right slice of data that takes all of those issues into account and can properly allow the testers to test the application? Here they are, again, listed the three traditional approaches. You either clone or copy, subset or sample, or generate or synthesize the data. And the problem is, in all of those cases, we have the reliance on a shared database. So I have these three applications and these three testers testing them, and they're all accessing the same database, regardless of the three approaches I outlined. Well, we pull that data from the database and we operate on that data, either by cloning, subsetting, or using the rules of that database to synthesize the data. And then we push that data back into another shared database. So there are two problems here. And the first one is the time, the delay it takes to synchronize the schedules of those different testers and making sure that we're putting that data into the right scope for the right testing activities at the right time. The second challenge is that because we're putting that data into a centralized database, we still have this challenge of data conflicts. As John is working on their application, they could be updating tables that Sally is going to want to use, potentially in its original state before John got a hold of it. And in this scenario, everyone is living in the same environment, colliding with the same database, plus data pollution becomes a reality. And these problems can slow down our ability to effectively test our applications, or worse, corrupt or invalidate our tests. So what is the solution, or a potential solution? There's a fourth option, and that is using service virtualization. Service virtualization allows you to simulate services, databases, backend systems, and to make them available as if they were actual services, and then augment existing environments or create simulated environments, allowing individuals to test anytime, anywhere. So let's just go into a little bit more depth about what service virtualization is. So, the pros and cons of service virtualization. Individuals have the autonomy to provision data without having to require a centralized database. By using service virtualization here, you're virtualizing the vehicle that's delivering your data. It also allows you to carve out your own little slice to do exactly what you want it to do. Corner cases, positive or negative, nominal, non-nominal, performance. These are all the pros to it. Now I'll tell you there is a con, or I like to think of it more as a heads up rather than a con. While you can virtualize various types of behaviors, it's not a real database. So when it comes to changing the state, it is 100% achievable, but this is where you need to make the differentiation between different types of testing that you're doing. And when you're validating your application, you need to take that into account. So companies today have so many options to choose from when they're selecting which automated testing tools they want to use to test their applications. And we have solutions that are out there, open source, free, maybe something like Parasoft. And the challenge is a lot of these require development expertise to test, as well as each test tool has its own result that then has to be aggregated into some consumable format that means something to the tester. And Parasoft has you covered with various JTests, C++ tests, SOA tests, load tests on the API side with smart API technology, covering all the way from mobile to mainframe and focusing on our APIs and our database tests, stringing those together into a meaningful omni-channel test experience that really validates the user's requirements. Now, as many organizations reach that state of omni or multi-channel testing, the problem shifts to those back-end or dependent resources that our applications have to be able to access in order to complete their tasks that we're trying to test. Resources that are needed may become unavailable or have associated costs that discourage diligent testing. You may not be able to control the behavior of that asset, as would be the case with the centralized shared database that I referred to. Or perhaps you're having to wait on another team to complete their piece of the puzzle before testing your part can begin. It could be any number of reasons. Even maybe your particular organization is structured in a way that load or performance testing is reserved for a specific group external to yours, and you have to wait for them before you can declare testing complete. And a lot of these are really just test data challenges. But wouldn't it be great to know that your application can continue to roll past these issues, or that your part is resilient and fully capable before it moves on to downstream testing? And so this is where service virtualization comes in. And what we're trying to do is you have the ability to where you can virtualize any particular state. So you could virtualize server errors, you could virtualize malformed responses or expose security exceptions. And we take an environment-based approach to testing. This here is our continuous testing platform, or CTP, where you can graphically define your specific topology in a model that you can then save configuration instances that are a combination of on-off, live or virtual, and then toggle between those live or virtual assets for your particular testing scenario. And we can package those different applications up into a scenario that can be delivered to an individual tester right to their desktop so they can test in a local way against their application with virtual dependencies, as well as being integrated into the overall CI/CD pipeline, where this containerized environment that has all of these test cases, virtual services, test data, and all the different configuration we require can be deployed as a function of code check-in and orchestrated with container services such as Docker and Kubernetes, potentially on-premise or in the cloud, to allow us to incorporate this anytime, anywhere testing that has all of the right behavior that we need. And the goal here is, by being able to control this more holistically, we'll be able to get better test results. And that's the real objective at the end of the day. So how do we virtualize? Virtualization is typically a 5-step process. You have your application under test that your developers have been working on, and you have your testing tools. You have SOA test, JTest, C++ test, load test for performance testing, and the application will have back-end resources that it will have to access, like databases, REST or SOAP services, or other applications. And our first step is to define monitors or proxies that intercept the communications between our application and its back-end systems. Next is to go about the steps that we want to take in our test while pointing at the live resource, and then capture that. We then collect that information, those transactions and data, and use them to create our virtual asset. And the virtual asset includes responders that will return data in the same way that the live resource responded to those same exact requests. And Parasoft Virtualized does this all for you, and they can be completely customizable or as ultimately simple, depending on what you need. I'll demonstrate creating those later in our demo. And then the next step is to deploy those assets to our virtual service repository. And that will allow us to consume them anytime, anywhere. Now, this is the point where most virtualization solutions stop, but there's a key component here, and that's the orchestration of those virtual services. We have some kind of CI management process, such as Jenkins, Azure, DevOps, GitHub, any of those different platforms. And through Parasoft CTP, we can coordinate the activity of these proxies that were first used to record the traffic to now redirect traffic to our virtual services. And the final step is to then consume the virtualized asset and the tests now being transacted virtually. Now, we can use our newly created virtualized asset in combination with test data or test data modeling to provide, as I said, a fourth option to the test data creation problem. So now, if the original problem with those first three options that we looked at was that shared database, service virtualization gives us the ability to decouple from that centralized database by providing virtualized databases. And what this allows for is for individuals to have their own representation how the data will be delivered to them. And the vehicle is simulated. It's not a real database. It's a virtual system. So we then have the ability to combine that simulated delivery mechanism with our test data modeling system, which allows us to visualize the data that's available to us, which we gathered from our record and playback. We take that data and we can actually see the shapes and relationships of that data. And we can then, in a self-service way, choose the different types of data that we want for our individual testing activity. We can design it, provision it, deploy it, and ultimately destroy it. And this gives us greater data consistency while reducing the amount of data redundancy that's out there. And we refer to this simulated data asset as a data source that we in turn assign to our virtual asset. I'm now going to take you through an example where I'll demonstrate recording a simple test, and then I'll show you some pretty cool things and abilities of Parasoft Test Data Manager. So now let me flip to my browser. Okay, so this is Paratroopers, and it's going to be our sample application under test. And so I'd like to draw your attention to this Parasoft logo up here in the corner, and I'll drop this down. This is our Parasoft Recorder plugin for Chrome. And we see here that I have the ability to capture UI actions for Parasoft Selenic to create Selenium tests, or I can capture API traffic for SOA tests to generate API tests. And in this instance, we're just going to record for our API traffic, and I'm going to start my recording. So this is the equivalent of setting up my monitor or my proxy. Now, I just want to consume. I just want to capture that step 2, and so I just want to start stepping through my test scenario. So I'm going to sign in here as purchaser. And then Paratroopers is our online store for military equipment. And so I'm just going to purchase 4 Apaches and let's also add 4 tanks. Add that to requisition. 1, 2, 3, 4, apply. Okay, and now I just go to my shopping cart and everything looks good here. So I'll proceed to submission. And this is our basic checkout process where we decide where we want our assets deployed. We provided a platoon ID and assign that to the campaign. Give the campaign an ID, give it a code name, go to review. Okay, we just review this and everything looks as what we've requested. So we submit that for approval. And now it has created this requisition number, which now has to be approved by a higher authority. So we're actually done with our test. So I will sign out here. And now I can stop my recording. So I will just come here and say, stop recording. And the first thing it asks me is, for my recorded API traffic, what is the, what do I want to identify it as in SOA test? So I'm going to call it demo API test. And I have the ability to associate it to my work tracking system, such as Jira or CA. And I can just create my test asset and watch what happens to the logo whenever I hit that create test asset. Because we see is what it's doing is that it's coordinating with, okay, so that completed. It was coordinating with my SOA test. And it was using our smart API technology to transform those recordings to API tests. So let's go into SOA test and have a look. So this is SOA test. And if I were to come in here and drop this down, we see demo API test. And so if I were to run this, usually the first time takes a little longer. So we're going to run it again, but let me show you just a couple of whiz bangs about this. Our smart API technology doesn't just do a record and playback of hard-coded values. It actually uses what we call a JSON data bank, where our AI reads the responses that come back from the server, and it generates a data model where it detects that there are values that should be parameterized. And so these can then be used, like I think here's a good example. So here's a good example where we see the URL has both hard-coded values and these parameterized values. And then probably one more I'd like to show you. Okay, so here we have the same thing. We have a JSON data bank, and then we have a JSON asserter. So the AI has determined that this is a dynamic value that could change. And when it does change, this is what the value should be. And so obviously to create this kind of in-depth test suite manually would take a very long time, but we did it with just a few clicks. So now, like I said, it usually runs faster the second time once it's run through once. So now we'll run it again and we'll see what happens. Okay, look, we have an error here. So let's take a look at that error. Okay, so it says there's not enough inventory to fulfill our order. So let's take a look at that. Let's go back here, and we're going to go to approver and sign in. And now this is that higher authority that I mentioned. And so what we see is that we've reached the limit of our inventory. We're pretty much out of stock of helicopters and tanks. Now, fortunately for our application, we can just come into here and reset the database and confirm that. And now go home. And I see no orders exist. So now when I rerun my test, and we see it ran in less than a second, or in a second, and everything was successful. But that running out of inventory is a perfect example of why we would want to virtualize an asset. So this is a limitation that we bump up against after 3 simple tests. And so what I want to do is I want to then create a virtual asset of paratroopers and that for my test. And so that's what I'm going to show next. And so to do that, I go into Parasoft Virtualize and I drop that down. And I say virtual asset, right click, and I say add new virtual asset. And I can come in here. And the first thing it's asking me is to name it. So I'm going to call it demo application. And then next. And now I want to choose create parameterized messages, which I explained with the JSON databanks and asserters, etc. Next. And now I want to point to my traffic demo file. So I'll go to my file system and select that demo API test and say, okay. And then now this wizard gives us all sorts of options and selections. And in previous runs of this, as long as I'm testing the same application, I can collect those and just create a traffic template from it. Now, if I changed applications, I'd have to create a new traffic template, but it's this easy to just recreate additional virtual assets. And so I just say next, next, and next, and okay. And now it brings me to this page where these are the responders that is going to generate from the various tests that we gave it. Now I have the ability to come in here and edit any of this information. I can change the HTTP method. I can change the URL path, whatever I want to change in that responder to alter the behavior. But in this case, I'll just say finish. And so that's what I did. I created it with just I named it, I selected the recording file, which is reusing the same recording file from our tests. And so now it's done. And then I click next, 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 finish. So now we can come here and take a look. We'll drop this down and we see that it's the exact responders that we saw in the wizard. And each of these is parameterized, etc. So, and here I have my data sources. So now what I want to do is link those two up. And so what I want to do is I'm going to now drop over into my CTP product, which is going to be our graphic web-based system that everything will be graphic now. So here we have my environment manager where whether I'm doing my test from web browser or whether I'm doing it from SOA test, they're hitting the server. And then the server is in turn hitting its backend services, like we talked about, for paratroopers. So what I've done is I've imposed this monitor or proxy, and then here's my virtual asset that I created. And so what I want to do now is I'll come here, and right now we see that we're pointing to live, our live asset. So I'm going to edit this diagram. And then I want to say, okay, right now everything is live, right? We see a live here. That's when the test comes through the server, it hits our proxy and it's going to paratroopers. So now what we want is we're going to click virtual. And so our test is going to run. It's going to hit our server and then go through our proxy. And then the proxy says instead, go to our new virtual asset. So we want to hit the play button to provision that. and everything passed, so everything's good. So now what we should see, where we had one item here and we just ran a test against it, we now have no orders because now we're hitting that virtual asset. So we could actually use CTP and we could just rerun this test by hitting this same play button, and that whatever we've assigned into this test executor could be a full suite of tests and all runnable by just a push of the button. So we see everything passed again. So shall we do it a third time? Because that was really, the third time was the one that finally killed it. So we see, yes, okay, as we knew, it was going to pass. And our paratroopers, when we refresh it, it shows still no orders exist. So we're obviously now pointing to that virtual asset. And because we're pointing to that virtual asset now, and because this is a test data demonstration, then I'll just come into here and we can look at our data two ways. Okay, the first thing we could do is we drop down categories get. And if we drop this down, we see that we have 6 elements here. So if I go to here and I log out and I sign back in as my purchaser, these are the 6 elements that we're seeing, the 6 categories. So I'll go back and now I can view my data in this JSON hierarchical way, or I can view it graphically. And it's going to generate a graphic representation of the model. So these lighter blue dots are our table equivalents, and our these orange rectangles are the fields associated to that table equivalent. And then these darker circles are the queries that are actually querying those tables. Now, and I'll zoom into this to give you a better view, but if you're not familiar with your data model, then you just key in the word that you know, categories, and so it says, here's my categories get, and then it zooms into that specific one. And then it has the ability to walk the model. So it then says the next one we want to go to is content. And so here we see content is actually, if what the next thing we're going to get is our content item types. Let me just pan there a little bit. The content is going to be the query to get our content item types. So this is where we want to specify how many of these that we want. And so let's generate 100 items. So let's generate 100 categories. And so we go to mask and generate settings, and we specify a minimum occurrence and a maximum occurrence of 100. So we want 100. And then the next step is to continue walking the model to the content item type. So now we're here. And so what I want to do is I want to generate 100 unique IDs, and then I want their names to reflect those IDs. So I'm going to come over to, I can scroll down, and okay, there's name, there's ID right there. So I come to ID, and I've got my 3-button menu here. I go to mask and generate settings. And now we have the ability, when we generate this data, we can generate a range. We give it a minimum, a maximum, and it'll generate the range. It can randomly choose numbers. We can say from a seed, I will give it the seed value and then increment accordingly from there. And then we also have the ability to do formula, which I'll explain with name. But so right now we just want a range. And we'll start that range. It's a number. You also have the ability to create date ranges. So we'll start that range and we'll say 1 to 10,000 is the default. Now, since we're only pulling back 100, 10,000 as a maximum is fine. So we'll just leave that, and then we save that. Then let's go to name. In name, we'll hit our little 3-button menu here, and we'll go to mask and generate settings. And let me clear out my formula here so that you can see me create it. So here, as before, I showed you ranged, random, and from seed, but here's formula at work. So formula works just like standard spreadsheet formula functions. And so in my case, I'm going to use the concat. So I click insert function. And what I want to do is say category, and then space, and then comma, $, and then curly brace. And when I hit that $, curly brace, just like you saw in our JSON databanks with what those parameters look like, it uses the same nomenclature. And so it says $curly brace, and then it gives me a list of all the fields that I can use. So I want to use ID. So I click there, and it closes my curly brace for me. And so now I just save that. And now I just go to generate data. And it says I'm going to do all of these changes, and everything looks good, so we generate. And so now if we go back to our database here, we can look at dry run generated, and here it is. So we can view it like that, or we can view it like our tabular hierarchical JSON data. So I drop this down, and so if I go to content and I go to content item type, and we now see we have an array of 100. So what we want to do is we want to link that to our virtual asset. So for that, I want to go to virtual assets, and these are all just accessible here. I've just got them in separate tabs for my ease of use. So I want to go to my virtual asset. Here's demo application. Drop that down. And then for my data source, I want to say that anytime we're talking about we're getting categories, that instead of using my total traffic dry run, I want you to use my newly generated data. And then we'll save that. And when we go back to paratroopers and we refresh, we now see that we have 100 categories, all with the name, category, and then the ID number. So I can also, that was generating data from nothing. Now I can also go into my model, and I have the ability, now that I have these 100 categories, let's say that I want to mask them. And so this is a pretty snazzy thing right here, is that whenever you click infer constraints, what it's going to do is analyze all of those values and determine what those data types are, what the formats are, any patterns within that data. And then it's going, so now we can look at it. I believe it was this one. I did it. Okay, good. Content item type. So see, it's come in here and it has recommended what values that we should have. So So like here's name. So if we look at our data constraint settings that it generated, is that it tells us that it's a string and the pattern is a category. And then if we look here under the information icon, it tells us that we have a random digit for a hashtag or a ampersand, or we can use a backslash to escape and have that character in there. So what we want to do is we're going to go into we're going to change it. We're going to hashtag it here, and we're going to say ampersand, ampersand, dash, and then we're going to give it ampersand, ampersand, ampersand. So that's our new structure that we're going to mask over that existing category, etc. So we'll save that. And then we come to mask data, and then we hit that. And it's going to generate that same, okay, it says that exists. So it's just going to override it, no problem. So we then click mask, and we generate this database. And so now I want to go back to my virtual asset, and I'm going to say, instead of using dry run generated, instead use generated masked. And so I'll save that. And now when I come to paratroopers and refresh, I have now masked the same data that I generated. And so I can use this if I want to overwrite email addresses or social security numbers, etc., or names, right? It can all just be random generated values. And so that reaches the end of our demo. So let me go back to our presentation. Great. So now let's review. So what we went over is the ability to understand the data that we have, capture that, and put it into a virtual service to navigate that data and to take a look at the data that you have and store it into a repository, a data source. We can then move on as we capture and then ensure that it's safe for use in our testing environment. We then go beyond that by looking at the shape of the data, understanding the relationships and the constraints, and then generating additional value. And from that, we then carve out just the data that we want for our particular testing situation. And this just makes the whole challenge more approachable and intuitive. And by combining service virtualization with the ability to simulate a database, you get access to select type queries and get API calls. And with test data management, which we would reserve for databases that require stateful activity where actually interfacing with the database and changing the data to a particular state, by leveraging Parasoft's test data manager, you get the best of both worlds. And we can model different types of data and understand the relationships between that data, understand the values for it, and generate whatever data we want into a disposable virtual data source that can be linked to a virtualized asset in our test environment. And so it looks like I was a little talky, and so we're at the end of our demo, but we'd like to invite you to attend our upcoming Automated Software Testing and Quality Summit scheduled for November 4th. This half-day event will feature companies from multiple industries that are sharing their continuous quality journeys. And you can find more information and register at the link shown, or you can scan the QR code there. And we ran out of time for questions, and I apologize for that. And if you had posted a question in the Q&A box, we will get back to you with an answer. And as always, if you want to request a personalized demo of anything you've seen today, just submit a request to our website. And if you'd like to get started with Parasoft Virtualize, you can download the Community Edition. And be sure to check out our website for any other great resources such as white papers, case studies, and blogs. Thanks, and have a great day.